All right, guys. So you may also want out your two graphic organizers from yesterday and the day before. Kylie, can you hit the light? Yeah. All right. So today, what's wrong? Let me see if I can override yours. Okay. Try it now. I think since I started my session, it should have taken you out of your other teachers. All right. So today we are continuing on with our proofs. All right, now we're moving away from triangle and into quadrilateral. All right, so I want to go ahead and take care of this because, proofs are a pain and I'd rather not spend an hour and a half on them. So rather 45 minutes and an hour and a half. All right, so I'm on page 7. All right, so perhaps the most important of all of the special quadrilaterals is the parallelogram. Because any quadrilateral with two pairs of opposite parallel sides are considered a parallelogram. Now, the important properties of a parallelogram that you need to know is that adjacent angles are supplementary and the opposite angles are congruent. Those are the two major things, besides that there's two sets of parallel sides. All right. So, in the diagram below, line M is parallel to line N, and line S is parallel to line T. The intersection points are shown, creating a parallelogram ABCD. So in other words, just to recap, M and N are parallel, S and T are parallel. So I'm going to go ahead and mark them with my little arrow ticks. So first off, we're going to list a pair of adjacent angles. All right. So remember, adjacent means that they share a side. They're connected to the same side. All right. They're not diagonal from each other. They would be either to the left of them, to the right of them, above or below them. All right. That's what adjacent is. Opposite means they're diagonal from each other. So can someone name me one pair of adjacent angles? A and B. So angle A and angle B. What's another? B and C. B and C. All right. Someone else besides Jasmine who's got another pair. C and D. Yes. That is what you said, right? D and B, they're opposites. We're looking at adjacents. But C and D are. And then there's one more. What is it? A and D. And again, all of these would equal 180 degrees because they're supplementary. Now, why do you think that is? So let's think about this logically. What is the total number of degrees that all the angles of a quadrilateral adds up to? 360. Now, we also know that the opposite angles are congruent. So that means that these two are congruent and these two are congruent. All right. So we're going to explain how those pairs are supplementary. Because if this all adds up to 360 degrees, and I'm just looking at two of those angles, if they're not the two congruent angles, what should they add up to? 180, half of one. We're looking at two angles out of 4. That's half of 4. Half of 180, half of 360 is 180. So that's why they're supplementary. Also, in terms of parallel lines, so looking at parallel line M and N, what relationship do angles A and D have to each other? They're what? So what relationship do these two angles have to each other in terms of parallel lines? So is it like alternate interior, alternate exterior, same side interior, same side exterior, corresponding? What do you think? Same side interior. What's true about same side interior? They're what? They're supplementary. So the main reason is that all of these are same side interior angles, which are supplementary. All right. Now, it then wants us to prove that angle ADC, so in other words, this angle right here, is congruent to angle ABC, which is this angle right here, thus showing opposite angles are congruent. So, if we want to start this proof, here's how I would do it. So there's two ways we can do this. We can either do this as a flow proof or we can do this as a statement reason proof. I would probably do this as a flow proof. It's a little bit nicer to show. So our end goal, which we can already put at the end, is we want angle ADC to be congruent to angle ABC. Now, the only statements that we were given comes from the top that I highlighted in green. All right. And those would be if line M is parallel to line N and line S is parallel to line T. All right. And our reason for that is it's what? It was given to us, right? That's what they told us up here, that these lines were parallel to each other. So our reason is that it's given. Now, our other reason is that ABCD is a parallelogram. And again, those were given to us. So we then need to make some connections. Yes. Yeah. So we then need to make some connections. All right. So we're showing that opposite angles are congruent. So typically, if we're talking about parallel lines, why do you think we're going to end up with the opposite angles that are congruent? If we're talking parallel lines here. So guys, if this is given and this is given, we can technically already prove this because of why.
Taking this as his final attempt. Whatever it is, that's what it is.
Aaron gave me this, and I gave it to him, and he didn't even take it.
He didn't make any questions. That's fine. That's me.
Yep. So guys, if we have a set of parallel angles, all right, So let's just start going around with this. All right. So first off, if we have two sets of parallel lines, all right, we can then show, and that it's a parallelogram, this can bleed into the fact, let's use our pair of adjacent angles. All right. Let's say that angle A plus angle D equals 180. The reason for that is same side interior. We can then say, using the exact same statement, given statements, that angle A plus angle D is equal to 180 degrees. I mean, angle B, sorry. Again, because of same side interior. So I'm just going to leave this reason in the middle between the two because they're the exact same reason. Same side interior. So thus, these two both tell us that actually, no, not angle A. Let's do angle B and C. Mm-hmm. No, it's A and B. Angle A was Nope, I was right the first time. So angle A plus angle B is equal to 180. Again, by same side interior. Now, given that angle A is the same, that means we can then show that angle A is congruent to angle A because of the reflexive property. Thus, that proves that those two angles, or angle D and angle B, are congruent because two different angles, or no, the sum of the same angle. How do I state this? I know what it means, but I just got to state it right. It's not transitive property. It's and the reason is if two angles are supplementary and one angle is the same, then the other angle must be congruent. So if two sets of angles are supplementary and one angle in each set is the same. Sorry, guys, I'm just really trying to get the wording right. Is the same, then the other angle must be congruent. So what I'm trying to say is that with angle A, since angle A is the exact same angle and they have to add up to 180, that means that angle D and B have to be congruent. All right? Because, for example, if angle A equaled 100 degrees and we add angle A to angle D to equal 180, that means angle D has to be what? So again, if angle A is equal to 100 degrees and angle A plus angle D equals 180, that means angle D has to be what? So same angle A is 100 degrees, plus angle B has to equal 180. So B has to be what? 180 or 80, sorry. So that's what I mean by that. If you're adding something to the same angle, then it has to be congruent. Delta Math states it better than I just did. I just could not get the wording correct, but that's essentially what's going on. All right. It's basically the sum of two angles. If in a sum of two angles, two sets of a sum of two angles, you're adding the same angle, the other two angles must be congruent. All right. Okay, that was disgusting. So let's try a different one. So, side properties of parallelograms is that opposite sides of a parallelogram are congruent and they are the same length. So, why we claim that angle 1 is congruent to angle 3 and angle 2 is congruent to angle 1. So, why can I say that these two angles are congruent and these two angles are congruent? Why can I say that? Because they're what? They're alternate interior angles. If we're looking at parallel lines, and this is the transversal, those are clearly alternate interior. They're on opposite side of the transversal. So it's because they're alternate interior. So what theorem do you think we could use to show that those two triangles are congruent? So we got two congruent angles, and we can also use the what? The shared side right here. So what theorem is that? So guys, we got two angles and a side, so that's what? Close. It's the other one. Angle, side, angle, because we have two angles with a side in between them. So angle, side, angle, that's how we can prove it. Now, once I can conclude that those two triangles are congruent, I can then say that these two sides are congruent because of what property? Not because they're parallel, but think about it. Whenever we were proving that sides or angles were congruent after we proved a congruent triangle, what was always the reason? CPCTC, that the corresponding pairs of congruent triangles are congruent. That's how we prove it. All right. Now, the diagonal properties of parallelograms. So the diagonals of a parallelogram have the same midpoint. Another way of saying is the diagonals of a parallelogram bisect each other. So in other words, it cuts them in half. So they gave us a proof here where all we got to do is figure out the reasons. All right. They already gave us all the statements. We're just figuring out the reasons. So this shouldn't be too bad. All right. So they already said that given a parallelogram MNPQ, we want to prove that MP and QN bisect each other. So the first thing that they state is that MNPQ is a parallelogram. What reason would that be? It's just given. They told us that. They then say that MN is congruent to PQ. So MN is congruent to PQ. Why do you think that is? What's true about a parallelogram in terms of its sides? The opposite sides are congruent. So the reason for this is opposite sides of a parallelogram are congruent. All right. Then it says that MN is parallel to PQ. And why is that? It's just the definition of a parallelogram, two sets of parallel sides. So I would just say this is the definition of a parallelogram. Because the opposite sides of a parallelogram are always parallel. So from there, we start getting into some congruency. So they're saying that angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. And I could say that because of what reason? Yes. Yes. Alternate interior angles. If I drew these parallel lines, both of these diagonals could be considered transversals. I have opposite interior for 4 and 2, alternate interior for 1 and 3. So the reason here is alternate interior angles are congruent. Thus, we prove that those triangles are congruent by what postulate? So these two triangles are congruent by what postulate? Angles. You're right. Angle, side, angle. Because we got two angles with a side in between them. Thus, MR is congruent to PR, and QR is congruent to RN. And why is that? Nope, can't say that yet. That's what we're trying to prove. But there's something that we just proved that also tells us that. What did we just prove in the previous statement? No, I mean statement 5. So what did we prove in statement 5? So the triangles are congruent. Are those sides not made up of the two triangles that I just marked? Yes. So that means that they're congruent because of what? If we have two congruent triangles and those sides happen to be on the congruent triangles that we already proved are congruent, they're congruent by CPCTC. Thus, MP and QN bisect each other. Why? Isn't that just a definition of a segment bisector? That's what I would say. If you have two sides that are congruent, that means it cuts it in half. So that's just a definition of a segment bisector. All right, any questions on that one? All right. Last little part, and then I'll help you a little bit with the delta math. All right. Huh? We got like 20 minutes. All right. So just as with parallelograms, there are conditions that must be sufficient to prove that a figure is a rectangle and has 4 right angles, one of which is by using the diagonals. So if a quadrilateral is a parallelogram, the parallelogram has congruent diagonals, then it's a rectangle. So in other words, if we can show that the diagonals are congruent, then it's a rectangle. Because rectangle is the only shape in the hierarchy besides a square, which is lower in the hierarchy, that has congruent diagonals. All right. So if we are given ABCD as a parallelogram whose diagonals BD and AC are congruent, all right. So in other words, BD is congruent. So this whole diagonal is congruent to AC. So why is triangle ADC, or this big triangle right here, congruent to triangle BCD, or this triangle right here? Why do you think that is? Yes. Right. So their hypotenuses are congruent because that was given to us because their hypotenuse is the diagonal. And then they also share a what? They share a, what's the side of a right triangle called that's not a hypotenuse? A leg. Now, we haven't proved that we have 90-degree angles yet. So another way we could say it is that if we know that this is congruent to this is congruent to itself, and this is congruent to this, it's by what? Because we already know that if it's a parallelogram, opposite sides are congruent. If they share a side, it's congruent. And they told us the diagonals are congruent. So what triangle congruence postulate does that give us? Side, side, side. Now, what can we say about angle ADC and BCD given that they're congruent? So in other words, what can we say about this angle and this angle given that they're congruent? Or given that the two triangles are congruent? They're what? They should be congruent as well because they're by CPCTC. So how can we use B and the properties of angles and parallelograms to conclude that both angle ADC and angle BCD are right angles? What's another thing that we could say about this, about these two angles? In terms of a parallelogram, they're what? So forget about the triangles for a second. If we were looking at that in terms of a parallelogram, they would have to do what? Or be what? Not just congruent, but also supplementary, because they're consecutive or same side angles. They're adjacent to each other. So on top of that, this angle plus this angle is equal to 180 degrees because adjacent angles of a parallelogram, and I'm just going to are supplementary. So if those two angles are congruent, but they also have to add up 1 to 180, what is the only angle measure that they could add to, that they would have to be individually? 90. Because if they're congruent, but they add to 180, that means you're just dividing 180 by 2, which is 90. So because 180 divided by 2 is equal to 90, because they're both congruent. Or no. Since both angles are congruent and supplementary, that means that angle ADC equals 90 and angle BCD equals 90. And again, because they both are congruent and supplementary to each other. And that's just logic. If they're congruent but at the same time supplementary, they can only be 90-degree angles. All right. So I know that was a lot and it probably just went straight over your head, but we're going to at least try to do some of this delta math, the new one. All right. I just want to get you started on it. Okay. So look at the new one that says proofs with quadrilaterals. There's a couple of single problems we're going to do together. So I'm looking at the very first one. So while I'm waiting for you guys, I'm just going to go ahead and plot the points just so we can save time.
I don't know. Whenever my eyes close, I guess.
So the goal of this, listen up. Shh. We're just going to, so I'll have this in the video. So let's just do this together and then you can go back and plug in yourselves in a little bit. All right. We're just looking at the first single problem. But my goal is to show that this shape on the graph is a rhombus. Now, there's a couple ways I can do this. All right. What's the only thing that has to be true about a rhombus specifically? All the sides are of equal measure. All right. Now, there's only one way that I can do that. All right. So, you technically learned this back in Math 1, but we're just going to have to work our way around it. So, there's two ways you can do this. You can either do this through the distance formula of the points, or, this is one I highly recommend, diagram here. All right. So, how it works is each side is going to be considered a hypotenuse. You're going to draw in 4 different right triangles. So, this first one, what was it at, like -6 something? So, I'm going to draw from P all the way down to M to make this right triangle. And the reason I want to use Pythagorean theorem is the legs we technically already have the lengths of, because all we have to do is count the units on the graph. So how long is this short side right here? So in other words, if P's at -4 and M's at -6, how many units away is that? So guys, how do I get from -4 to -6? It's 2 units. So this is 2. Now, P is at 1 to get to -8. So how many units does that have to be? Yes, 7. No. It would have to be a -1 to do that. I would say 9. Because it's 8 units to get to 0, and then 1 more to get to 1. So now we can do a squared plus b squared is equal to c squared. This would be 9 squared plus 2 squared is equal to c squared. 81 plus 4 is equal to c squared. So 85. We know we're going to have to take the square root. Let's get rid of that square. It's equal to c. We're just going to leave it like that. All right. You could simplify the radical, but to be honest, I just want to prove that the sides are congruent. So just leave it like that. All right. So this side right here is the square root of 85. Now, the next side I would want to test is the one that's opposite from it. Because if this side is not congruent to this side, it's not even a parallelogram, right? The opposite sides at the very least have to be congruent. All right. So again, I'm going to make another right triangle. So n is at an x value of 1, O is at an x value of 3. So I'm going to go 2 units over. It's almost like you're doing rise over run, guys. All right. And then n is at -2, O is at 7. So I'm going 9 units up. So do we even really need to do work again for that? No, because we already did it. So this has to be the square root of 85. Now we can figure out these two sides. All right. So n is at x value of 1. M is at an x value of -5. So I'm going to slide over n. Oh, yeah, whichever. -6 to 1. So that's how many units? 7. Because it'll take 6 units to get to 0, and then you add 1 more. Then it goes from -2 to -8. How many units would that be? 6. This would be 6. This would be 7. And then we just do Pythagorean theorem. 7 squared plus 6 squared is equal to c squared. So 49 plus 36 is equal to c squared. So that would be 85. Take the square root. Square root of 85 is equal to c. So we got 3 sides that are congruent. Then we just got to show the last one. All right. So I'm going to draw my triangle. And then it will work out that this would be 6 and this would be 7. So we would still get a square root of 85. Does everyone kind of understand how I set that up? All right. That's the easiest way to find those side measures if you're given a grid. You can also use distance formula, but honestly, it's long, it's complicated, it's a pain in the butt. Okay. All right. So we know that this is square root of 85. I'm just going to leave that up here while we put it back in. So this is square root of 85. We already showed that. So that means for all of these side lengths, yes. 5.2 quadrilateral proofs. Yeah. So that means that all of these are square root 85, and we're putting in square root 85 so we have exact measures. So all the sides are equal. Since all the sides are equal, it must be a what? A rhombus of some sort. That's all we got to do. So once you use Pythagorean theorem to figure out that all these sides are congruent, and that's just by making right triangles by doing rise over run between 2 different points, and then treating the side lengths as the hypotenuses, it's really easy to figure out. So submit. Yes, should be correct. And again, they use distance formula, But as you can see, distance formula is a pain in the butt. Pythagorean theorem is so much easier. All right. You can do it both ways, but this is easier. All right. So we're going to stop here for today because I can tell you guys brains are fried and I fried it very quickly. Try that Delta math over the weekend if you have time. We'll do a slight bit more on Monday, maybe just as a warm up, and then we're just going to have to move on. All right. Again, proofs aren't a huge part of the EOC, and they're honestly not that big a part on your test. And the only parts that I would say on your test is for like I will give you most of the reasons and most of the statements, and you just have to fill in the blanks. All right. That would be the only thing that I would expect from you guys. You're not going to actually make a proof from scratch. I promise you that. You're not going to have to make a proof from scratch. So, at the very least, if you can verify why a statement is what it is or why a reason, like what reason describes what statement, that's all you got to do on the test for my class. Okay? Does that kind of alleviate your worries a little bit? All right. And when we get to the review phase for the tests, which is sometime next week, I will kind of I'll show you guys some tricks and stuff. All right. Okay.